Hi, myself Sudeshna. Today I am going to present the project on analyzing and forecasting construction cost in Calgary. So the today's agenda is like that. First, I'm going to discuss about the project overview, then how I clean and prepare the data, doing some exploratory data analysis. Next, the outlier detection and transformation. After that, I'll be moving towards creating the different machine learning models like XGBoost, stratified modeling, and finally I'll provide the result and insight based on the result. And I've also provided some screenshot of my Power BI dashboard and the Streamlit application. And the last is the conclusion and the future work. So the project objective is like that. The core objective for this project were very clear and focused, aiming to provide actionable insight for the city planners. So the first objective is the finding the project cost, the predicting the project cost. The project analyzes 25 plus years of Calgary building permit data to uncover community trends and build a predictive model to estimate the project cost based on the permit attributes. And the basically it also helps us or support the city planning, enhance budgeting, resource allocation, and long-term cost forecasting for urban development by leveraging a Power BI dashboard and interactive Streamlit web app. And the project also helpful to identify the key drivers. What are the key drivers? Like pinpoint the most influential factors impacting the construction cost within the city. Next, I'll be discussing about the data set from where I have collected the data set. So the foundation of the analysis is a rich data set from the City of Calgary Open Data Portal. And the data I have collected in the data set, I got the data from 1999, June 22. And over there I got the records like 4,72,000, and there in the data I have got the 30 columns or 30 features over there, such as permit type, status current, application date, work class group, estimation, project cost, community name, total square feet, like that. So I have used Python for analyzing the data. Over here, first I have in the right side, we can see that I have used the command, the data frame, the df.info. So after storing my CSV file into a data frame, I am just checking that what is the structure of the data, or what are the columns available, how many null values are there, what is the data type, like whether it is a categorical, whether it is object type, or whether it is numeric type. So in order to get that information, I have used that command, the df.info. So here we can see that there are 30 numbers of features available, and from there I am focusing on the estimation project cost, because this is my target feature, or the target variable, you can say. From that estimation project cost, you can see that it has data of 4,36,000 and seven kind of data available over there. So we needed to do some analysis that what are the how many missing values are over there in every features, and whether we need to clean, whether we need to remove. So based on that, we have like I have created one chart over here. From that, it is very easily visible that for each and every feature, how many missing values are there. So here you can it is visible that high missing values in total square feet, like 68% missing values in the total square feet, and contractor name is like 40% and applicant name is 30% missing values are present. And in my target variable, that is the estimation project cost, is also having some missing value like 7.36% records, that is the data is not present over there. So it is critical since it's the prediction target. So So as it is my target variable, the records which is not containing that estimation project cost, I needed to remove those data from my data set, or from my data frame rather. So initially, as I mentioned, that we have the records like 4,71,419 records over there, and after removing 34,723 data, we are currently having the 4,36,696 records. So next we'll be doing some analysis, the exploratory data analysis, so that it is we are able to understand how the data, what are the different features, how they are related to the estimation project cost. So we do some analysis first. So first I want to see check that what is the distribution of estimation my target variable, the estimated project cost. So from the chart, it is very visible, it is easily visible that the data is highly skewed. So like as we know that we have that much current record over there, 4,36,000 and 696 records, and the mean is like 2,68,381, and the standard deviation is 3.4 million, indicates wide variation in the project cost. So that is one of the concern over here, that the data is highly skewed. And here you can see the minimum value is like $1, and the 25th percentile is like 25% project cost is less than 15,171, and the half of the project cost less than 54,145. So the basic statistics of that my target variable is visible over here. Next I'm focusing on different like analysis, or I want to solve some business questions. I want to check the distribution of the data. So in order to do so, I created different charts to check how the data is distributed, how the estimated project cost is related to other features like permit type, work class, contractor name. So how the data, my target variable, is related to other features. So my first question is like the permit volume over time. So here I'm mainly analyzing the trend analysis, that how the like how many permits are giving per year. So in order to do so, first I need to extract the year from the application date, because the year explicitly is not provided in the dataset. So from the application date or from the issue date, I needed to extract that year, and then group by year and count permits, visualized as a line plot. So based on the line plot, it is visible that permit volumes generally shown an increasing trend from 1999 to 2024. So there is a every year the increase, there is an increase like in the rate, the number of permit count is also increasing. And there are some fluctuations such as dips around 2008 and 2000 to 2010, maybe corresponding to some economic downturns. And the next is like the sharp increase in 2024 could indicate a construction boom, or data reporting differences. Maybe the data reporting differences will be there. And in 2025, as we can collect up to July, the data is collected up to July. So that's why the 2024 5 data, it's like the graph goes down over here, might be because I was unable to collect the entire data, because it's up to July I was able to collect. Next, I analyze that which work classes have the highest median estimated project cost in Calgary building permits. So here we can see the work classes are present in the x-axis. There are different work classes like new, air conditioning, repair, addition, alteration, temporary, fire or security alarm. So based on the work classes, I tried to find out what is the median cost. So, and this chart I have used bouquet for bouquet bar chart to showcasing that, because that is interactive. And from the result or from the visualization, it is visible that the new construction or the air conditioning or the HVAC installation exceed 150K as a median, and the moderate are like repair, addition, alteration range is like 20K to 35K, and for the fire security, that is the low cost, under 10K. So the insight help prioritize which permit type are cost intensive and require closer financial oversight. Next, I'll try to analyze the. I'm trying to analyze. I try to analyze that how does the average estimated project cost related to the average number of housing unit across different permit class group. So, what approach I have taken? I first group the data by permit class groups. So, what are the permit class group available? In the right side, it is visible that apartment, government, institutional, industrial, townhouse, commercial, that are the permit class group present. First, I calculate the average estimated project cost and average number of housing units, visualize with a scatter plot to identify trends or correlation. So from the inside, it is visible that in the right hand side, it's like pink color, the apartments and government projects laid in both cost and housing units, indicating large scale development. Means for the apartment, I can see over here, the housing units are also increasing, and the average estimated project cost is also increasing. So because in the case of apartment might be the number of units are higher. So that's why the housing unit, it is very relevant that housing units are increasing. In the same way, the average estimated cost is also increasing. But for institutional and industrial have high costs but fewer units. Maybe the number of housing units is not that much present over here in case of institutional industrial in some related to that particular project. But the cost is higher in this case, institutional and industrial project level. So this is very relevant insight and visualization for the in with respect to the uh, business. Next, the question is coming that which communities have the highest total investment in projects. So first, it is very necessary that which community is giving where the number of estimate project cost is higher. Like for that, I first segregate total estimated cost, project cost by community, convert amount in millions so that it is easily visible and it is understandable, and then I sort and visualize the top 10 communities. And from the result, it is visible that the downtown commercial correlates with a total investment of 8.83 billion. And next come the belt line, follows with like 6.89 billion, reflecting vibrant urban development. So these are the top 10 communities from like 1999 to 2020, mid of 2025. So the communities, and that is most active communities with respect to the estimated project cost. Next, which combination of permit type and work class tend to get approved the fastest on average? So it is very relevant question that which kind of work class or which kind of permit type is that kind of project get approved easily. So for that, I group building permits by permit type and work class and calculate the average approval duration and count of permit for each group. Filter for groups with sufficient volume, like more than 100 permits to ensure statistical significance. Then visualize the top 15 fastest combination using a horizontal bar chart. So it is visible over here. The residential permit, especially repairs and alteration, receive the fastest approvals. Like you can see, the residential improvement project and the improvement project is like the days often accepted under 10 days. Commercial addition and environmental restoration alteration experience the longest delays, averaging 60 to 180 days. Next question is like the which contractors have the highest average estimated project cost so far. So here from the visualization it is visible that in the Rockport commercial tops the list with a project cost value 228 million, and other major contributors are also there like the ITC projects up to 68.58 million. In ITC project is also visible that it is not only work on the new projects but also some alteration projects are also there working. So this analysis is very much useful like for the applicant, for the layman user also, so that they can also connect with that kind of contractors to if they needed to do some work or with respect to the new alteration or addition. After doing that kind of analysis, next I'm trying to showcase some chart that is the in like like a dashboard to visualize some chart in the map format. So here I have developed an interactive dashboard using Dash, that is one of the library in Python, and Bouquet to visualize the estimated project cost of building permits by community over different years. So here it is very relevant that in a particular year, what is the estimated project cost for a particular community. So here I have in the dash, I have given one drop down over here. From the drop down, it is very easily to select the year. Like here I have selected the year 2024, and from that year I can see that particular community EPK, the community code is EPK, the community name is Elbow Park, and the total project cost is this. And finally the permit count for that community is 48. So for each and every community, how many projects or permits has been given, what is the total cost is very easily visible, and the bubble size is based on the magnitude of project cost. So here you can see there are two bubbles, maybe in the downtown or belt line, they have the largest estimation project cost. So the size of the bubble is quite high over here. Next, after doing some exploratory data analysis, doing some visualization, we are moving to do some feature engineering. So what is the need of feature engineering? If the features we have already 30 features available, but sometimes it requires that we needed some extra feature for our analysis for the modeling. So creating new feature from existing data to enhance model performance. So as the first feature I have taken is the log estimation project cost. I have in the first slide we have seen that our estimated project cost or the target feature is highly skewed, so it really affects the model uh, training. So that's why I first transform the project cost into natural logarithm transformation I need to do. And after transforming the data, you can see the distribution of the log estimation project cost is like that, and it's not that skewed. The skewness is gone over from this distribution. In addition to that, I needed to add some extra field like square feet per unit, and the square feet per unit is coming like that total square feet by housing unit. That is the formula I have used. In addition to that, I have used the approval duration, completion duration, and the calculate. I have calculated from the existing column like issue date minus applied date and complete date minus issue date. Now, do I needed to do some categorical encoding also, like for some features, categorical features like the contractor name. There may be several contractor name present over there, or the community name. There may be several communities present over there. So I can't consider, I was not able to consider all the communities, because whenever I'm going for modeling, I needed to convert the categorical data to some numerical data by doing some one hot encoding or the label encoding. So if there are like thousand number of datas are there, thousand number of communities are there, I need to convert into thousand columns for one hot encoding. So it is very difficult. So that's why I created one column, like community name. I created a community name top. So what is the concept? What approach I have taken to create that column? So first I check that top 10 communities. I take all those communities over there, but the rest of the communities I stated as other. In the same way, I have also taken the status current top, also contractor name top and permit class top. So if the number of like if there are so many permit class available, like more than 300 or 400, so then I needed to do like this, and there are so many categories, then I needed to create this kind of encoding. Next, the another important thing is whenever I'm going to generate any model or doing the model training, that is a feature. If there are so many features available, which feature I needed to consider, which feature is relevant, that is also very essential to understand. So in order to do so, there are different approaches available. Like for numerical features, we can see the Pearson correlation. So based on the Pearson correlation, that is we can see over here, the total square feet is highly correlated with the estimated project cost and the log estimated project cost both. Moderate importance seen in approval duration, completion duration, and housing units. And geographic features like longitude and latitude have minimal correlation. So maybe we don't will not consider, whenever we are going to do the model training, we will not consider that kind of features like the longitude and latitude. And for categorical correlation with the target data, we have I have used the ANOVA over here. What is ANOVA? It measures if different categories of a feature have a significantly different mean value on the continuous target. So it helps to identify informative categorical features before encoding and modeling. And from here in the chart, we can see there are if statistic and p-value has been given. The low p-value indicate a strong relationship between the categorical feature and the target, and prioritize top features with lowest p-values and highest if statistic for feature engineering and model building. So for model building will be, you can see over here, all tested categorical features significantly influence the estimated project cost, with work class mapped, permit type and work class group showing the strongest effect based on high F statistics and non-zero p-values. So it is easily visible that the categorical, how they are correlated with the log estimation project cost. So that is relevant, that work class mapped and permit type is really most important feature for model creation or model training. Next, another thing I needed to consider here, the missing value. If there in the model, there are so many missing value that we have seen in the first slide over there. I already showcased that there are some missing values present, and high missing values present in some particular field like total square feet. So I needed to either delete the data, sometimes I need to impute the data. So based on the requirement or the analysis or the necessity, I have to do the imputation. So first I have done the numerical imputation for total square feet, because it is very important feature, as I have showcased there, that is correlated with, highly correlated with our target variable. So in order to do so, I first created a group key by combining permit class group and completion duration to capture project specific context, and use the group median to impute missing total square feet values. Additionally, there are some values are also remaining. So in order to impute those values, I have to use a His gradient boosting regressor model to predict the remaining missing total square feet values for improved accuracy. Next, I need to do some categorical imputation. Like for some categorical variable, I have seen like a work class mapped has some missing values like 3000 missing values are over there that I imputed using the work class group to maintain categorical consistency. And also some duration, approval duration and completion duration records are missing. So to impute that, I first group by permit class group and work class group to preserve the contextual accuracy. And then I take the median value. So in that way, I impute the data for the approval duration and completion duration. Next, the removal of the outliers. So what are the outliers? Outliers are those things like maybe sometimes we given the data that should not be given there, like for some uh, extreme cases, extreme values are there. So that might impact final analysis or final modeling. So to reduce the noise, like extreme values are either removed or capped to mitigate noise and improve data quality. It also helps the stable model training, resulting in significantly more stable and reliable model training, enhancing prediction accuracy. Preserved high-valued data, valid large projects were kept separate for specialized high-value analysis, ensuring no critical data were lost. So there are several outlier removal also I need to do over here. So first, the duration filter. That the duration we have seen that we have taken two uh, features over here, inserted new features like approval duration and the completion duration. So we need to check over there whether the approval duration is within the 0 to 365 days. We have set one cap over here, and the completion duration is 0 to 1000 days. Then only we are going to consider that data, the record. Otherwise, we are removing the data. Similarly, for the estimation project cost also, as you can see in the picture, the data is highly skewed. So we needed to do some things so that the skewness some way it should not be not like that. So we have used the IQR or interquartile range method for removing the outliers. So after doing the IQR, here you can see that the next picture in the C, the skewness somewhere gone, and here the distribution of the data is much better than that. And housing units also I needed to filter. In some cases, we have seen by doing the analysis or by the housing unit sometimes is given like -1. So that is not relevant, and that is that we should not consider over here. So we are considering the housing units that is greater than equal to 0. So validation checked valid entries for each filter separately and combined. And finally, we are moving with the data. Number of data is now 3,78,303 records are currently there for modeling. And what is the purpose of that? As we have discussed, the purpose of remove outliers or incorrect entries to improve the model reliability. Now coming to the training, the model training. So here I have used several model first initially to check that which works better. So I have checked with XGBoost, LightGBM, Random Forest, and CatBoost. So from the result, it is visible that XGBoost delivered the best overall performance on the both log transform and original skills. LightGBM was close second with minimal drop in accuracy, and Random Forest and CatBoost showed comparable but slightly lower performance. And performance difference, although very small, but indicating all four are viable, but XGBoost is optimal for this dataset. So we are moving to with XGBoost after that. So by doing some hyperparameter tuning, we are able to find the XGBoost final XGBoost model. And we have taken some column transformer, like for doing some numerical transformation I have used a standard scalar, and for in order to do the categorical data translation I have used a one hot encoder. Model use the XGBoost regressor and doing some hyperparameter tuning, and these are the features, and this is my target features as the log estimation project. And final, the model summary, evolution summary is like that. It is in the original scale, it is giving the root mean squared error is 46,193 and R2 score is giving 0.8434. So it is giving moderate result, but considering the scale of the data or the huge skewness of the data, it is quite acceptable. So, and the residual distribution is also showcasing that most of the error is near to zero. And after that, we are also I'm also considering another modeling, that is the stratified modeling for project cost. So what is the stratified modeling? Here I basically what is the objective over there? That to improve prediction accuracy by segmenting project into small, medium, and large cost groups and training dedicated model for each. So here first I divided into based on the cost. I first divided into three groups: the small, medium, and large. And this is a group, like if the cost is less than 14,000, I put it in the small group. If the cost is within the range, then it is in the medium. And if the cost is greater than 1,70,000, then it comes as a large group. So what is the need of the stratified modeling? Different cost ranges show distinct patterns and feature impacts. Helps avoid to one size fit all model, which may be skewed by large cost outliers. Significantly improve prediction accuracy when grouping is accurate. So if the grouping is accurate, whatever the data is present over there, if I consider the data and I created the group, then it is giving a good accuracy. Here you can see the root mean squared is coming like 22,350 and R2 score is like 90 0.9634. So it is quite good. But the challenge is coming when some new data come and I was not able to find that which group that belong. So then I needed to take something to find the group first. So that's why I first taken the XGBoost for checking the group, whether it belongs to the small, medium, or large. Then from that, after defining the group, then I can go for the particular modeling based on that small or medium or large. So then it is creating some issue, like it creating the model accuracy is not it's similarly like it is not outperforming the XGBoost. So that's why I consider the XGBoost for further model creation or for further application, for Streamlit application, or for showcasing the result in Power BI. So as I mentioned that during inference, project grouping must be predicted first by predicting the cost from exhibit regressor. If group prediction is incorrect, the cost estimation from the wrong model is higher. So that is one of the things, like if the whenever some new data come, the first I need to group the data, find the group, then only I can find the cost, final cost. Otherwise it is giving a um, uh, uh, good result than the XGBoost regressor. So that is one of idea over here. If I means I divided the data initially and then I tried to do this model training, then I think this stratified modeling will definitely work better. Finally, this is one Streamlit application I have developed, and here is the link to access. And here I have taken all the details that is required, that is relevant for this for finding the cost. So first the permit number, permit status, and work class group, work class map. So here I have given already the drop down list. From the list anyone can select, and they can find the estimated project cost. So by the selection I can see the estimated project cost is given like that. And next I have also developed one Power BI report. Over there I have taken 3 pages. So the first pages will give you the main overview, where I have considered uh, those data over here. And finally, next I'm going to showcase that what are the community respective community insight page. And finally I'm showcasing that what are the prediction insight, what are the, like here I have given some meaningful insight that is really helpful for the different stakeholders. So finally, coming to the conclusion, the project provides an end-to-end data-driven solution to analyze, predict, visualize Calgary's construction trends. It helps planners, developers, and city officials budget and prioritize uh, based on real insights. The tool developed are scalable and can be extended to other cities to permit types. And in the next step, I'm planning to incorporate real-time data feeds for ongoing prediction updates, and explore deep learning models for more complex pattern recognition, like in maybe in some features like the description. From that feature, if I was able to, I by doing some natural language processing, if I was able to find some meaningful data from the description, then we can use this for further analyzing. So that's all. Finally, thank you for your patient hearing.